4.5, analyzing lines of fit. Moving forward, in order to find a line of best fit, typically we're going to use a calculator. So using technology to find lines of best fit, when you use a calculator, the calculator is going to give you something that's called the correlation coefficient. Now, the correlation coefficient tells you how closely the line of fit models the data. So if your data has a very, very strong positive correlation, then your line of fit is probably going to model it very well. Versus if your data is not correlated, it's kind of no correlation, and your calculator finds a line of fit, then that line of fit is not going to model the data because it's just scattered around the graph. The correlation coefficient is the variable R. If your R value can only range from -1 to +1, it will never be 2 or 3 or 4. If the R value is -1, it has a very, very strong negative correlation, meaning your graph is going something like this. If there's no correlation, that tells you you've just got random dots, and your R value is going to be closer to 0. If you have a very, very strong positive correlation, meaning your graph is going like this, then your R value is going to be very, very close to 1. An actual R value of 1 means it's an exact perfect straight line. Usually you're going to get something like 0.9, which means it is going very positive, but it's not exact. Or you could get like -0.9, which again is not an exact line. It's just kind of very strongly negative correlation. Using technology. Example 1, the table shows the durations X in minutes of several eruptions of the geyser Old Faithful and the times Y in minutes until the next eruption. Using a graphing calculator to find an equation of line of best fit. Then plot the data and graph the equation in the same viewing window. Now, doing this in class, we're going to use the TI Nspire, but for those of you at home, it's probably going to be easier to do this on Desmos. So if you're at home, you can cross out these directions because this shows you how to do it on a TI Nspire, and you can follow along with me. First of all, open Google, and we're going to type in linear regression Desmos. And I spelled regression wrong, but it should be this first one that says statistics. We're going to do linear regression, and linear regression is what is going to tell us the line of best fit. Now, when you click on that, it's automatically going to give you a pre-made table, and we don't really want this table. We want our table, which isn't going to be too hard. We're just going to cover up these values. So, for example, our first X is 2.0, and then 3.7, and just you can pause the video at this point in time and take some time and fill in your X values, and I'm taking them right off the table. Once you get your X values filled in, go back up. We're going to erase our Y values and fill in the actual Y values. And then just check over your table and make sure everything looks right. Now, part of Part A said that we had to graph the scatter plot and the line of best fit on the same graph. Well, the nice thing about Desmos is that it already did it for you. We just have to kind of go up here and find it because our numbers are up here if you look in the 80s and 60s, etc. So we're going to kind of move our graph until we find our scatter plot. It automatically already graphed the line of best fit. So then we just have to take the information that it's giving us. Down here, do you notice y is approximately mx plus b? The first thing we're going to want is our parameters. It's giving us our m, which is our slope of 11.99, which is approximately 12, and our b of 35.1068, which is approximately 35. Make sure you write these on your paper. And then the other value you're going to want is this r value. Remember that r is your correlation coefficient, and it's telling us how related this stuff is. So do you notice that your r value, first of all, is positive, because this is a positive slope? And then do you also notice that it's 0.97? That's really, really, really close to 1, which is telling me that these dots make a really, really good, closely related line. They're not all perfectly on the line. You know, this one's below it, this one's above it, these two are kind of on either side of it, but 0.97, really close to 1, so these dots are really close to the line. Okay, back to your line. Part B, identify and interpret the correlation coefficient. So the correlation coefficient was that r equals 0.09787. Now, to interpret that, that's telling me that there is a strong positive correlation. Part C, interpret the slope and y-intercept of the line of best fit. So if you remember, we found that the slope was 11.99, which we're going to round to 12. We found that the y-intercept was 35.1, which we're going to round to 35, which gave us a line of best fit of y equals 12x plus 35. Our slope, if we interpret that, is the time until the next eruption increases, okay, and we're increasing because it's positive, by about 12 minutes for each minute the duration increases. Talking about the eruptions of Old Faithful. And then our y-intercept B is 35. Okay. This is the duration of eruption. Think about, like, this is where x is 0, which is the duration of an eruption. Well, if the duration of an eruption is 0, would we even have an eruption? Okay, if it's not happening. So here, this again is not really going to have meaning. So I'm going to put that as the duration, or how long of an eruption cannot be 0. Therefore, this has no meaning.